Hello and welcome to Inverse Relations Part 1. This is going to be very much an introduction to what an inverse actually even is. So here's what we got. I'm going to start off with a function, some sort of function which we could call f of x. Now what a function typically does is you take some number and you plug it into the function and then it spits out some kind of a result. So for example, let's say we picked the number 2 for no particular reason, and we plugged it into this function f of x, and it spat out, say, a 10. And it can do that a number of different ways, right? Some sort of mathematical function that does that. You know, maybe it just took the input number and times it by 5, for example, or some weird thing like that. Now, what is an inverse function or an inverse relation? Well, what an inverse does, if you take this, this is called the output, okay, and this actually is called the input. If you take this output and say you plug it into another machine or another sort of function, and say it takes you right back to where you started. Okay? In other words, it always undoes whatever this function did. Okay? It sort of, you know, this function here packages it up, and then this one here unpackages it, and back you are where you started. You see I wrote it with this funny notation here. This is called the inverse. Sometimes it's a function, sometimes it's just a relation. And we'll talk more on that later on. But an inverse always undoes what the function did. In other words, in the original function, this was a point on the graph. So that means that a point on the inverse would look like this. When we plugged in 10, it took us back to 2. Okay, so this would be our original function, and this would be a point on the inverse function or relation. That's a really good thing to know, because say you wanted to graph the inverse, all you got to do is, like, say you got a whole bunch of points here, like say you got, I don't know, 4, 0. Bing, there you go. 0, 4 is a point on the inverse. Or maybe you've got negative 3, 2. Bing, you just spin those around. And you've got all these different points that are creating a graph of the inverse. So it's a really, really cool way to produce this graph. Let me just show you that on a grid. So I think you're going to see something that's kind of neat too on the grid. So let's say you had some sort of a function, and I sort of figured I'd go with a square root function. Say you had something like these points here. So do something like this. Okay, so this is y equals f of x. And then I say to you, please graph y equals f inverse. Please produce that graph. Okay? All I'm going to do is take these 3 points and spin them around. So this one was negative 2, 0. Right? We had this. Negative 2, 0. So now I'm going to go 0, negative 2. So I'm down here. This guy is negative 1, positive 1. I'm going to spin that around, and it's now going to be 1, negative 1. Okay. This guy here looks like it's 2, 2. And hey, that's kind of funny. When I spin it around, I still get 2, 2. So that point is both on the original function and on the inverse. So I'm going to use a dotted line here, so it's sort of more clear. There is my inverse. There's my inverse graph. Okay. Now, there's a little trick here when you do these graphs that can be very helpful. I'm going to put a line in here, and it's going to be not just any old line, it's the line y equals x. Okay, so here's the line y equals x. All right, so this line, if you look at our original graph, and then you look at the graph of the inverse function, you can see, hey, aren't these reflections of each other? Aren't they just reflected across the line y equals x? And you would be absolutely correct. Okay? It's no coincidence. Okay? So reflection across y equals x is another way to spot what the inverse looks like. So let me give you an example of that. So let's clear the screen now, where this would be very helpful to know. Somebody comes along and says, I got this function, and it looks so, let's see here, maybe it looks kind of like this. Okay? Would you be so kind as to draw me what the inverse might look like? So you go, hey, no problem there, buddy. What I'm going to do is I'm going to put in the line, well, actually, here's a problem. I just got to figure out where I am here. The line y equals x. There we are. Okay, so this is the line y equals x. Okay. Now I'm going to, with the best of my abilities, try to reflect this original function across the line y equals x. It's not always that easy to do. I find it's almost easier if you tilt the whole thing sideways. Another way to think of it is if you put a lot of paint across the original function and then you fold it on the line y equals x, and then you pressed your paper together, where's your paint now? So that's kind of another way to think of it. So I got this guy going like this, it looks like. Oops. Something like that. And then on this zone up here, it looks like it's kind of doing that. So this would be my best guess as to what the graph of the inverse would look like. I also see it doesn't look like the inverse here is going to be a function because it's got too many of the same y values on a vertical line. But we'll talk more about that later. I think this is probably a good place to stop. And like I say, we'll pick it up with inverses part 2.